friends, in this lecture I would like to explain another topic based on the earthquake analysis. So already in the previous topics I explained so many examples, that is one way slab, two-way slab, column analysis and design. In that again biaxial column, uniaxial loading conditions, and again two-way slab wind load analysis, tower wind load analysis. But in this example I would like to explain another topic based on the earthquake analysis. See here, open the Staadpro Connect software. So give your file name. So I will give EQA, which is earthquake analysis, and location. Choose your default location wherever you want to store the file, and type will be analytical, units will be metric, and then click create here. See here, then your default user interface will be opens like this. So this is your default user interface. Here in the geometry, select structural wizard. See here, you will get a dialog box like this. Here first in the file you can select the units. So in the file go to select units, and then so you can change feet into meters and then click OK. And then in the prototype models, by default it will be truss, you can change it to frame models and then choose bay frame. Okay, double click this one, it will, the parameters will be appears. Just click and apply how it will be. See here, this will be like this. This is a multi-story bay frame. So here if you apply multi-story frame as it is, so here it will be difficult to provide plates individually for each and every floor. That's why what I am doing means, first I will restrict this floor to only one floor, then I will increase this steps to this floors to multi-story. For that what I will do means, see here, I will reduce the height, that is only for the first floor, that is 3 meters, and number of bays along lengthwise will be 1, and then apply. See here, this will be only first story. So first you can transfer this model as it is into the Staadpro software. Okay, see here, this is single story frame connecting with number of bays. Then so first you can create the plates, and then you can increase the number of plates. For that again the geometry, sorry, first you can create generate mesh. For that in the geometry go to generate mesh. So here you can select create mesh option. So see here, first you can select this node and again this one, 4 corners of the building. Then again you can close up to the point where you started. If you select this add plate option, there will be 4 nodes only you have to select. But by generate mesh option you can close where you started, and again it will be asking here which type you have to choose, an polygonal mesh and quadrilateral meshing. So quadrilateral meshing in the sense it will close to 4 nodes. Polygonal meshing means you can touch up to 5 nodes. So for that you have to close the 4 nodes only, that is quadrilateral meshing. Okay, and again one more dialog box will be appear. So here for showing the difference between add plate and generate mesh only, I am showing this type. In the last previous 2-way slabs I draw the plates through the add plate option. So there we select only 4 nodes, but here from the generate meshing option you will get one more dialog box extra here. So what is the difference means, so here for each and every area in the AB in the 3 meters there will be some 10 divisions. So here you restrict this one to 4 divisions, means here A to B you restrict only each and every individual plate, you can say individual bay you can selecting one plate like that. In the BC also, in the CD also, in the DA also. Click apply. See here, once you can go to select option and then select plate cursor, and you can select all plates means, so there will be 16 plates, 4 in X direction, 4 in Z direction. Totally 16 bays will be appear. So like this generate meshing option will be useful for creating individual bays. If you select this add plate option means, first you can apply only this add plate to only 4 nodes, and again you can apply for 4 nodes, or else you can create entire single story as one plate only. So that's why I am choosing this generate meshing option. This generate meshing option will be useful for number of bays. Okay, then once you created these plates, then you can increase the number of stories. So for that you can select the entire structure. For selecting the entire structure, again you can go to select. So select the geometry option. So geometry cursor option will be useful for selecting entire properties, that is for beams, columns, nodes, plates, all the things. Okay, see here it will be selected all the properties. Then again in the geometry, select translational repeat command. Again one more dialog box will be appear here. So in the y direction, so number of step spacing will be 3 meters only. Why? Because already first story we selected 3 meters. For that here also I am selecting 3 meters, and I will increase n number of steps. Maybe I will choose somewhat higher only, that is number of steps will be 8, like that, and then click OK. If you see, n number of bays will be created, first store and 8 numbers. So totally 9 story will be there here. And again if you select plate cursor and then you can select plates, each and every floor plates will be assigned. So this way first I choose single story frame, then I created plates, and then I will increase number of steps. Okay, then our next step is first create the supports for the story. First select the supports and then create the supports. There you can choose fixed support, click add, and again select the supports. First view your structure in 2D mode, then select the bottom nodes and again view your structure in 3D mode. Check once whether your nodes will be selected or not, all nodes, then assign it to the selected nodes. And then next will be properties. So here the properties will be define the properties. Okay, so first you can define the properties. I will choose rectangular here, so 300 by 230 mm, so which is 0.3 by 0.23 in meters. Click add, close. So this property only I will apply both for columns and beams. Okay, so select this one, select beams parallel to y axis. So first apply for the columns and then click assign, and again select parallel to x axis, select parallel to z axis, and then assign it to the selected beams. See here your property will be assigned for beams and columns. Then create thickness for the slab. For that you can select thickness and increase your thickness, that is 0.15, 0.2, your wish, and then click add here. Okay, see here you can assign this plate by selecting the plate cursor. You can select the entire plates on the story, and then you can assign this plate to the selected nodes. Okay, see here your plates, beams and columns will be assigned. Okay, then in the view again select the 3D rendering view. You see whether it will be assigned or not. You can check here, plates also created, even columns also assigned, and beams also assigned. Then our next step is loading part. So here in the loading part only we are analyzing earthquake analysis. For that select loading here, and then in the definitions you can select seismic definition, click add here. Okay, here it will be by default UBC 1985. Here select to Indian standard. There will be 3 codes. You can select any one which you are familiar. I will select Indian IS 1893. Okay, here you will get like this. Here you can click generate loads. Okay, see here after selecting this one, so the zone factor will be there. For city Agra, Z will be equal to 0.16. If you are familiar with these cities, you can go these cities. For example, you people are staying in Anantapur, so Anantapur comes under which zone? For that what is the zone factor? Like that you can select based on the cities only. If you are not familiar with the cities, you can select zones. Okay, so there will be some 4 zones like 2, 3, 4, 5, and for zone 2 it will be 0.1, and zone 4 it will be 0.24, and zone 5 it will be 0.36. So what is this z value and how by default it will be selecting like this means, just observe in the code once. See here, this is your Indian code where which I selected in the Staadpro 1893 part 1 2002. So here seismic zone 2, which is seismic intensity is very low at seismic zone 2, and the z value, that is zone factor value, will be 0.10. If you choose 5 means automatically it will be highlighted there 0.36, which is very severe. Like that each and everything will be there in the code. And at the same time for rock and hardy soils, SA by G also calculated according to the code only. and at the same time for periodic coefficients of x and y directions also calculated based on the code only, and at the same time each and everything will be there in the code. For example, factor will be given 1 means damping percentage will be chosen as it is 5% in the Staadpro connect. If you select Indian standard once means automatically it will be selected, no need to give manually all the values, but it is always better to for designing purpose you can check manually once. Okay, then here in the zone 2, so I will select very severe zone just for trial purpose. I will take some values here. Again the response reduction factor, there will be so many. For example, if you are designing shear walls for earthquake, you can select this one, and at the same time you are designing load bearing masonry walls, you can go for this one. But we are not under load bearing walls, already structures will be created through beams and plates. Then therefore by default I will select special RC movement resisting frame. Here the damping ratio will be 1, for that the percentage for this general building will be 1, therefore damping ratio by default it will be selected 5%. So soil will be changes by your own, you can select whatever you want, either hot soil, medium soil, you can check once in different formats. So the structure type will be keeping RC frame, steel will be comes for wind tower, trusses, all the things. So I will choose RC frame building only, and then click generate here. See here each and everything will be there. So periods in x direction, z direction, manually you are familiar means you can select that one, otherwise you can leave that one. Staad itself selected manually as usually. Then click add here. Once you can click add, automatically the zones will be highlighted here. Then go for self weight factor will be by default it will be 1, click add here, and again select member weights. Member weight will be the loading type will be taken here uniform. Okay, and what about its weight? So its weight, you given the property of 0.3 by 0.23, and that for that you can add some multiply with unit weight of RCC, which is 25 kilonewton per meter cube. So for that you just check once what is the value. See here, it is better to calculate, otherwise take some approximate value. See here in the utilities you can select this calculator and then select the value 0.3 by 0.23 by unit weight of RCC. Click OK, that is 1.725. So here I will give 1.725 in minus. Okay, then click add, and again go for floor weights directly. So floor weights pressure, so how much pressure we give? Already your slab thickness is 0.15 into unit weight of the RCC. Click highlight, that is 3.75. So again you will give minus 3.75 kilonewton per meter square. So Y range will be starting from first story here, this point to the top point. So already how many floors we created? Up to here 3 means already 8 will be created. 3 8 is 24 plus 3, that is 27. So that is 3 to 27. So we know in the y direction, so this is around some 12 meters taken from first 0th node to 12. Means in the x direction it will be from here to here, in the z direction it will be from here to this end, that is 0 to 12. Each and everything will be selected here. Click add, close. You see, first you can apply this uniform weight to the members, that is select parallel to x, select parallel to z, then assign to the selected beams. So this floor load and all it can be applied as usually. So then once it will be completed, then click the load cases and then click add. So here first you can come from seismic. So for seismic loads always you can apply first, and then only you can go for dead load and live load. First choose seismic load x and that in the x direction. Click add, and again seismic load in z direction. Click add, and then again the seismic load, click minus x direction, title will be minus x, and again in the seismic loads that will be minus in z direction. So there will be 4 parameters. Again in the x direction click add. So in this dialog box you select seismic loads, so the x factor will be 1, you can select this one, add, close, and again in the z direction click add, and again in the seismic loads you click factor 1 add, and again in the minus x direction click add, and again in the seismic loads you can select factor as -1, that is minus x direction, click 1 add, and again in the negative z direction click add, and again in the seismic loads you can select -1 factor, click add, close. So you no need to apply all these individually. Why? Because by default itself will be analyzes. Okay, then again click load cases, add, then you can choose dead load as usually, that is give some name for better indication, dead load, and again you can give live load, give some indication which is live load, click add, close. First you can go for dead load, click add. So you people know what is dead load, self factor for all the structure, that is -1, click close, and again live load, click add. Just I will apply loads for the floor load only. Why? Because already I gave uniform load in the earthquake analysis. Then click floor load, and again pressure will be -3.75, -3.75, and again in the global y direction minimum y range will be 3 to 27. I already told you how to take in these values, and again x value will be 0 to 12 in the x direction, and again z direction 0 to 12, click add, close. Once you can apply the self weight here as an interview, so it will be applied to the entire structure, and then just you keep your cursor like this, automatically so each and everything will be selected. If it will be not selected for range from 0 to 27 and 0 to 12, just to go to edit option and you can change whatever the values you want here. Okay, so then your analysis for the load analysis will be completed. So you can, if you want, you can go for auto combination loads, you can generate auto loads also. So first you can complete analysis up to here, click analysis, define commands, click all, close, and again go for run analysis, save the structure. See here, you see whether your earthquake analysis will be applied to the frame or not. First you can analyze this one. If there will be any errors, check once. See here, there will be 0 errors. Then you can go to the post processing mode. See here, then you can select all the loads, apply first. Okay, then see here, in the post processing mode, first check the deflection in the y direction. You see, is there will be any deflection in the y direction? So the blue color marks indicates the deflection in the y direction. And again, you can go to the x direction deflection. See here, this is the deflection in the x direction. And again, you can check the deflection in the z direction. Okay, see here, this is the deflection in the z direction, whatever the red marks indicates here. Then you can check the reactions. So there will be heavier values. Okay, that's why it will be clumsy. Then in the movement y direction, you check once in the movement y direction. So first we will go for animation, then okay, then again we will check movement x direction. Okay, first you can check the animation here, and again in the animation check the deflection, and then click OK. See here, we are in live load, that's why there will be no deflection. The deflections are very narrow. If you change this one to x direction, you observe the deflection will be taking place in x direction. Okay, and again if you choose for z direction, then it will be changes to z direction. So the deflections will be like this. Then again you can go from minus x direction, just the deflection will be changes to the negative in the x direction. And again if you keep negative z direction, then again your deflections will be changes to the negative z direction. So that's what the earthquake load will be applied in all direction. So that's what you observing in the, that's what you observing here in the post processing mode, and that too in the animations. Then again in the animation you go to place stress contour, and again here you can select maximum absolute, and again in the animation select stress here, and then click OK. If you see here how the stress will be applied on the plates here. Okay, then again in the post processing mode, again go to analytic mode. So first you can check in the post processing mode, movement in y direction. See here how are the movement in y direction. So if you can apply maximum load means the moments will be heavier. So this is movement in x direction. So this is movement in z direction. So each and everything you can check. Okay, and again you can check Staad output also. So after the design I will show you Staad output file. Before that we can go to the design part, again in analytical mode, select design. So each and every time you can select the parameters as concrete. Okay, then you can select the Indian standard 456 2000 and again select your parameters whatever you want, that is FC compressive strength of the concrete, and again FI main yield strength of the concrete, FI secondary strength of the concrete. Click OK, and again you have to define the parameters whatever you given. So for by default I will choose M25 grade concrete, that for that 25 into 1000, and again click add, and again FI main will be 415 grade HYSD bars 415 and again 1000, click add, and again FI secondary, again it's also I will choose by default it will be 415 grade only, click add, close. So you can go to the commands, you can select, there will be designs in a multi-story frame, beam, and again design column, we have to design that columns also. So click add, and again you can take for plates slab element also, click add, and then finally take off for each and every element, click add, close. So you can apply each and everything. FC characteristic compressive strength of the concrete for entire structure, for that assign to view, click assign, OK, and again FI main reinforcement also for the entire structure, click OK, secondary reinforcement for the entire structure, click OK, and again design beam only select for the beams parallel to the x direction, beams parallel to the z direction, click selected to the beams, and again design column only for the parallel to the y axis, click assign to the selected plates, and design element only for the plate, for that select plate cursor, assign to the selected plates. Okay, then again check analysis, define commands, click all, add, close, and again run analysis, save the structure. Already I shown the variations before a design itself. Then again you can go for the design as per Indian standard 456 2000, click see the output file. Okay, done. Okay, see here, this is your Staad output file. Okay, see here. So in this you can check once what is your concrete design for beam and column and all. So you can check once the concrete design, each and everything will be obtained here. See here, this is your concrete design for beam. So what are the lengths you give, cover will be taken as it is by Staadpro itself. So what are the minimum cover we have to take, and each and everything it will be satisfied as it is. So you can check each and everything in the Staad output file. Okay, and then again you can check for individual column what is the reinforcement. Okay, so this is the reinforcement for that particular column number 653. So again you can check for individual beams also what is the concrete design, it will be in the beam. Okay, what is the reinforcement, what is the shear bending, loading, deflection and all, you can check individually. Okay, then you can also check the plates how it will be, the concrete structure and all. So this is beam. So if you want you can check for plates also. For plates there will be no such type of diagrams you will get, you can calculate individually based on the area of the steel. So this is how the earthquake analysis and design. Thank you so much for watching this video. If you really like this video, please like this video, share it to your friends and subscribe our channel. Thank you so much.